perceived as the most complex of the three spanning tree modes supported by Cisco switches, multiple spanning tree, or the MST, is going to be our next topic. I'm going to do now something that I haven't done a lot in these video series, but I am going to do it now. Please, before you proceed and watch this video about the MST, I beg you, watch the other videos that cover other operational modes of spanning tree, the prevalent spanning tree and the rapid prevalent spanning tree. The reason for that is that MST's perceived complexity comes from the fact that it draws on all those concepts of other spanning trees and then it builds on top of that. So if you are struggling with concepts from especially rapid prevalent spanning tree or the rapid spanning tree, you are going to have some difficulty understanding what MST does. So what I'm going to do now is I'm going to ask you to go back, watch those videos again, get those concepts solidly down so that we can proceed and explore what is actually different in MST in comparison to those other modes of operation of spanning tree on Cisco switches. Of course, if you have already done that and just recently watched those videos, now is the time to actually proceed. The first thing to note about the multiple spanning tree, or the MST, is that it's fundamentally based on the rapid spanning tree and all the good stuff that comes with the rapid spanning tree. Things like edge and non-edge ports, they are still there. All the handshakes and synchronizations, all those processes are there for the MST. So all the good stuff, all the benefits from the rapid spanning tree are there in the MST. Now, MST operates in something that we call the MST region. That's a group of switches that share the same MST configuration. The MST configuration consists of the MST region name, which is basically a string up to, I believe, 32 characters long. Then there is a revision number, which is just an administrative number that you set. So unlike VTP, where it's increased with any addition or removal of the VLANs or any configuration, with the MST configuration, with the MST revision number, this is an administrative number. It's a number that you simply set yourself. And finally, there is a VLAN to instance map. Now remember, MST supports multiple instances, and I'm going to talk about that in great detail in just a moment, but remember that what defines a region are these three things: the MST region name, the revision number, and the VLAN to instance mapping. Now, the real complicated stuff, the really complicated and complex part of operation of the MST comes when we are talking about the backwards compatibility of the MST with other types of spanning tree. Other types of spanning tree, non-Cisco implementations of spanning tree, like for example 802.1d or 802.1q, as well as Cisco proprietary implementations of spanning tree, like PVST and the rapid PVST. To operate in a backwards compatible mode, MST divides the whole network. That means MST region, other MST regions, and non-MST switches into basically several parts of that network. Now, that whole entire network is something that the MST calls the common spanning tree, or the CST. Inside the MST region, there is an operation of the spanning tree which is invisible to the outside world, to the world outside of that particular MST region, which is called the internal spanning tree, or the IST. Technically speaking, this is instance number 0, but I'm going to get back to that in, again, just a moment. And finally, inside that same region, all different instances, and remember VLAN to instance map is what defines these instances, are operating in something that we call the MSTI, or the MST instance spanning tree. There is a lot of stuff here that may sound confusing and may be a lot to fathom, so let me go ahead and explain a couple of these concepts. So let's talk about the MST regions. As I mentioned before, the MST region is a group of switches, a network of switches in the same network interconnected together that share the same configuration of the MST region name, or sometimes called domain name, which is a string of characters up to 32 characters long. And then we have the VLAN to instance mapping. Now, the important thing to understand here is that MST BPDUs that I'm going to talk about in a moment they don't actually carry this VLAN to instance mapping. What we are going to observe in the BPDUs is going to be a hash value that is going to be computed based on the local value of instance to VLAN mapping, or VLAN to instance mapping. Now, when BPDUs are received, these hash values are compared, and the switches know whether this value is the same or is not the same. And finally, we have the configuration revision, and as I mentioned, the configuration revision is just a number, an administratively set number that you can configure to be any number in the range from 0 to 65,535. Now, as you can see here, the configuration of these parameters couldn't be easier. All you have to do is say spanning tree MST configuration, you specify the name, revision, and the instance mapping, or VLAN to instance mapping, and you are done. Let me talk about the default values for these just for a little bit. The default value for the name is simply an empty string. There is not going to be a name, but there is going to be a value, an empty string, which is still a value. So technically speaking, where I said there that the name is up to 32 characters long, I should have mentioned that it could be 0 characters long as well, and it's still a valid MST name. The next is the revision number. The default revision, if you don't set one manually, is going to be 0. And instance mapping, or the VLAN to instance mapping, by default all VLANs are going to be mapped to instance 0. And in Cisco iOS you can have up to 16 instances defined. Or to put this in more practical terms, let's say that we have a couple of switches in our network, and these switches here are configured with these same parameters, and let's say that they're interconnected. It doesn't matter how they are actually interconnected. So let's say that these switches here are sharing the same domain name, they are sharing the same revision number, and they are sharing the same instance to VLAN mapping, or VLAN to instance mapping, so I'm just going to call this a map. So let's say that these switches here, they belong to the same MST region. So if these three here are the same, we can say that these switches here belong to the same MST region. But let's say that we had another set of switches, and these switches here may have had a different name. So let's say that here we had some name number 2, we had some different sort of revision, and we had a different or the same map, but at least the name is different. So these values here are the same, and these switches here would be in a different MST region. So this interconnection between these switches here, this is not going to be the same region. The different rules are going to be in action there, and those different rules I'm going to cover when I talk about the backwards compatibility with other spanning trees. Now, in this particular sense here, this is not a backwards compatibility with a different kind of spanning tree. This is simply compatibility with the MST that runs in a different region. So inside this region here and inside this region here, one set of rules applies, and here between these two regions a different set of rules apply. What I mean by set of rules is what kind of spanning tree we are running there. And remember, when it comes to the MST, there are different kinds of spanning tree. We have the internal spanning tree, we have the common spanning tree, and we also have the MST instance spanning tree running. So with all this in mind, let's take a look at how do we actually configure the MST and how does all this information look when it's transmitted in BPDUs. To do that, I'm going to use a very simple network consisting of just 2 switches. We don't need more than 2 switches to start with. So what I'm going to do here is I'm going to use my trusty Cat1 and Cat2, and I'm going to interconnect them with Fastnet 024 on both sides. And on Cat2, for example, I'm going to connect my Wireshark listening station on Fast Ethernet 03. And just as I have been doing so far, I'm just going to send the copy of this traffic received and sent on Fast Ethernet 24 to my Wireshark here so that I can examine what is happening between Cat1 and Cat2. But before I do that, what I'm going to do is I'm just simply going to enable this port and see what kind of BPDUs I'm receiving without actually observing what is happening between Cat1 and Cat2. And also I'm going to configure these two switches here to be in the MST region that is going to have the name, let's say Cisco. We are going to have revision, let's say revision 1, and I'm going to leave the default map so that all VLANs are going to be mapped to instance number 0. So let's see how this configuration is going to look. So I'm going to go to my terminal now, and here is my Cat1, and I'm simply going to say spanning tree MST configuration, and here I have several options to do. Now keep in mind one thing. This is very, very similar to our VLAN database. It's not the same, but it's very similar. It's very similar in a fashion that whatever I configure here now will not take immediate effect. I would have to exit out of this configuration mode for the changes to actually take effect. Let me show you what I mean by that. If I do show spanning tree MST configuration, this is the default configuration that I have right now. So if I do name and I set the name to Cisco, if I repeat my show MST configuration, take a look at what it says here. It says, first of all, the switch is not in the MST mode, which is okay, but the name is still unchanged. If I repeat the command now, I will see that the name has been changed to Cisco. So we can see here that the name changed to Cisco only by virtue of me exiting the configuration. This also means that in case I have changed my mind, so let's say that I went into my spanning tree MST configuration and I set revision number to 10. If I exit, this is going to take effect, but I can use the command abort, and with the abort command I'm not going to have any changes affected here, so I can see that the revision number stays 0. Now also another thing that I would like to show you is that by default we do have an instance configured. We can see here that we have one instance configured, and this is going to be our instance number 0, and we can see that all VLANs by default are mapped to this one instance. So let's go ahead and change this configuration to be what we actually want it to be. So I'm going to say spanning tree MST configuration here. I'm going to say name Cisco. I'm going to say revision number 1. And if I do show spanning tree MST configuration, this is what I will be seeing. Remember, until I exit, the changes I have made do not take effect. But now I can see that the change actually was effected, and I can see that revision 0 has been changed to revision number 1. This is something that you may want to keep in mind when you are configuring the MST, because it's very, very easy to get carried away and think that your configuration actually was affected, was executed, has been committed to the running configuration, but it wasn't until you actually exit from this sub-configuration mode. But this said, we still have to keep in mind that switch, even though we have MST configuration, is not actually operating in the MST mode. To do that, we actually have to change the operating mode of the spanning tree on our switch. We can do that with spanning tree mode, and we can see here that we have options MST PVST, which is the default, and rapid PVST. So what we want to do now is we want to change the operating mode to be the MST. With this change in place, now our switch operates in the MST mode. We can confirm that if you do show spanning tree, what we are going to see here is that spanning tree is enabled and that the protocol we are running is MSTP. And if we just do show spanning tree, what we are going to see is going to be the operating modes for all the configured instances, and by default we have only instance number 0 active. And we can see here that, for example, port Fast Ethernet 24 is now in a learning phase. If you watched rapid PVST videos, you will know that this is not supposed to happen. If both sides are operating in rapid mode, which is one of the prerequisites for the MST, this should have already transitioned into forwarding using the synchronization process and the handshake process, but it didn't, because this port here is actually a boundary port. So one thing that I want to point out about this thing here, it doesn't mean that this port is bound to anything. This is short of a boundary. This is telling us that this port, Fast Ethernet 24, is connected to a different either MST region or a different spanning tree domain. What I mean by spanning tree domain is that this other side is running, as far as this switch is concerned, regular spanning tree. Now, we know it's running PVST because that's the default, but this is how we are going to see it if we do show spanning tree. We are going to see that this is a boundary port, and then that on this port we actually have to fall back and operate in traditional spanning, using traditional spanning tree rules. Just like the rapid spanning tree or rapid per VLAN spanning tree would do. It would fall back to normal traditional operations of the spanning tree if it detects different kind of BPDUs coming from the other side. Let's then correct this. Well, technically speaking, there is nothing to correct, but let's finish our configuration properly. Let's go ahead and configure Cat2 to operate in the MST mode. And I'm going to configure it using the same parameters that I configured on the other side. So what I'm going to do here is I'm going to say spanning tree MST configuration. I'm going to say that name is Cisco, revision number is 1, and I'm going to leave my VLAN to instance mapping intact, and I'm just going to exit from this configuration mode. And if I do show spanning tree MST configuration, this is what I should be seeing. Now let's go back here and say spanning tree mode MST. So now I've changed my Cat2 to operate in the MST mode. And if I go back to Cat1, what I should be seeing here is that this is no longer a boundary port, so this is no longer effective. This is now the port, and I can see that this is now just a regular point-to-point port because the other side is operating in the MST mode. So this was very, very basic configuration of the MST. This was very, very simple. Now let's see those BPDUs. Let's see how these BPDUs look on the wire and what is the information carried in the configuration BPDUs for the MST. To do that, obviously, I'm going to go to my Wireshark. And as I said, this Wireshark has been connected to port Fast Ethernet 03. I'm not going to configure any mirroring. I'm just going to enable this port on my Cat2. So if I take a look at the configuration of Fast Ethernet 03, I see that the port is shut down. And I'm just going to bring it out of shutdown. And going to my Wireshark, I'm going to make sure that I'm capturing only the spanning tree BPDUs, and I'm going to start the capture here. So let's take a look at how these BPDUs look. So I can already see that I'm receiving some traffic, so I can stop this capture. I don't want it to scroll up and down. And let's examine what are the contents there. The first thing that I would like to point out is that we can see that the protocol version identifier is MST. It's going to be 3. So we see now here that this is a different kind of the BPDU. We can see that this is a BPDU type that is actually either rapid or the multiple spanning tree. And also, if I scroll down here, there are going to be some extensions. Now, these MST extensions, this part here, this part of BPDU is what we are interested in looking. This is where the information about our configuration is going to be transmitted and exchanged between the switches. The first thing that we can see here is the MST configuration name, and we can see it is what we configured it to be. It is set to Cisco. We can see the configuration revision 1, but this bit here is the interesting bit. This here is VLAN to instance mapping. And as you can see, it's fairly unreadable by humans. This is just a really, really large digest. Now, with this digest here, the switches will know if the configuration is the same. And it's important to understand that this digest will change when the VLAN to instance mapping has been changed. Let me demonstrate that. So I'm going to restart the capture. So let me start the capture again. And I'm going to be getting some BPDUs. Where I would like you to focus your attention is this field here. So we can see that this value here remains the same. So I'm now moving through different BPDUs that are being transmitted, and we can see that this value here, the VTP configuration digest, does not change. So let's go back to terminal. And just for fun, I'm going to say spanning tree MST configuration, and I'm going to change the revision to 3. Remember, it was 1 just before. So going back here, at this point here, if I scroll down, let's see where the configuration change happened. So here, at this point, we can see that the configuration revision is 3, and this is the digest value that we are looking. So I'm just going to scroll one packet up, and we can see that the configuration revision is 1, but the actual configuration digest is unmodified. So changing the revision does not modify this value here. Okay, fair enough. Let's change the revision back to what it was, and let's change the name to something else. Let's change it to Cisco. So I'm going to go back and apply this, and let's scroll down where this value has been changed. So there it is. Now we can see that the domain name Cisco, all uppercase, is there, but this value here is unchanged in comparison to what it was before. So we can see here that this is where the change happened, and we can also see that the revision number here is going to be changing. So this is where it was 3, and this is where it changed to 1 in all the uppercase, but we can see that the configuration digest remains the same. So this configuration digest there, that field, is where the information about VLAN to instance mapping is carried. Let me show you that as well. So going back to the terminal on cat2, I'm going to say spanning tree MST configuration, and I'm going to say instance. So now I'm going to create a new instance, and I'm just going to move VLAN number 10 there. Please take note, VLAN number 10 does not exist on the switch at this moment. So if I do show VLAN, I'm not going to see VLAN number 10. And this is not actually relevant, because this is a control plane information. This is just information, what are we going to do, what kind of logical topology we are going to be building, not exactly what VLANs we have. So spanning tree does not carry the information, or the MST does not carry information only about the active VLANs, because we didn't have 4094 VLANs to begin with, but it carries information in a case we have that traffic, in a case we want to have traffic in that VLAN. This is the logical topology that traffic would be following. So unlike per VLAN spanning tree, where we have one instance for every created VLAN, here we may have VLANs mapped to instances, and those VLANs may not be in use, or not all of them could be in use. And this is perfectly normal, because that's the whole idea behind the MST, is that we are not going to have a large number of instances. We're going to have a limited number of instances, and I'll explain why in a moment, why this is actually a good idea to have. So, but let's see what this little change actually did for our BPDUs. So at this moment, this change has not been applied. So if I do show spanning tree MST configuration, I'm going to see that at this moment, all VLANs are still mapped to instance 0. Going back to my Wireshark, let me scroll all the way down here, because this is where I want to start looking at it. So now when I exit, if I repeat my show spanning tree MST configuration, now I'm going to see that the instance, the VLAN to instance map has indeed been modified. What I can see here is that for instance 0, these VLANs have been mapped, and for instance 1, only VLAN 10 has been mapped to it. And if I go back to my Wireshark here, where was that boundary packet? There it is. So let's see where this thing actually changes. Should have been changed somewhere around here. Oh, did I actually apply the change? Yes, I have. There it is. This is where the boundary happened. So at this point here, so this is the frame where we can observe the difference. So at this point here, please take note what the MST configuration digest is. Now, the next BPDU here carried a completely different digest. It carried a different digest because our VLAN to instance map has changed, but the actual map is not transmitted in the BPDUs. It's locally kept on the switches, and then based on that configuration alone, the MST configuration digest is computed. So this tells us how to configure it, but it doesn't tell us why are we configuring these multiple instances. Well, let me explain that a little bit. Let's say that we had, again, just two switches. And let's say that, for the sake of this example, these two switches were interconnected by two links. And let's say that in this network, we had 10 VLANs. Now, for the traditional implementations of the spanning tree in Cisco switches, which, and by traditional here, I really mean PVST or rapid PVST, what we are going to have here are going to be 10 different logical topologies. By 10 different logical topologies, what I really mean is 10 spanning tree instances. Now, with these 10 spanning tree instances, what I have are really just two possible logical loop-free topologies given my physical diagram. So let's say that this is switch 1 and this is switch 2, that this is link 1 and this is link 2. Now, one of the possible logical topologies that we can have for this physical diagram here is that switch 1 and switch 2 have link 1 forwarding and that link 2 is blocking. On either side, that doesn't matter. Another logical topology, so this is logical topology 1, and another logical topology here is that we have switch 1, switch 2, where link 2 is forwarding, and then let's say that link 1 is blocking. So we have two possible logical topologies, but regardless of that fact, we are still going to be using 10 different instances of spanning tree. Now, if there is an overkill, this is one. So in order to address this, the MST actually allows us to map multiple VLANs to a single instance of spanning tree. So to solve this problem, to utilize all links in this network topology here, we don't need 10 instances of spanning tree. We just need 2 instances of spanning tree. So let's say that in our example here, these VLANs were VLANs 1 to 10. What we could do is we could map, for example, VLANs 1, 2, 3, 4, and 5 to, let's say, instance 0, and we could map 6, 7, 8, 9, and 10 to instance 1. Then what we could do is we could make this switch here root for instance 0, and we could make this switch here root for instance 1, for example. And based on that, we could also tweak the costs on different links here, or we could tweak the priorities on different links and come up with different topologies that actually result in different links forwarding. Or we don't even have to make different routes in this case. We could make switch 1 be the route for both instances and then tweak the costs on these links here or these links here to be more precise in order to affect which link will be blocking and which link will be forwarding. Let's see this in action. To do that, I'm just going to continue with my Cat1 and Cat2 example. And I'm just going to replicate whatever I have just described. So I'm going to have my Cat1 and Cat2. I'm going to have 2 links between them. This is going to be link fastnet 24. And this is going to be link fastnet 23. And I'm going to create VLANs from 1 to 10. Let's start by doing this. So I'm going to go to terminal here. And I'm just going to say VLAN 1 to 10, going to create those VLANs. Let me do that on both switches. So if I do show VLAN here, I'm going to see that I do have now my 10 VLANs created on switch 1. And I can, on my Cat1, and I can see that I have those 10 VLANs created on Cat2. The next thing that I'm going to do is I'm going to go to spanning tree MST configuration. And I'm going to say instance 0 VLANs from 1 to 5 and from 11 to 4094. So I want to have the default specific, all the other VLANs, I'm going to keep them in instance 0. And this thing here is one more thing that I think is very neat to know. So here I can use the same specification that I would be using when I'm defining or allowing VLANs on a particular port with switch port trunk allowed VLAN. So I can create either the range or I can list the VLANs. So for example, here I have two ranges from 1 to 5 and from 11 to 4094, and they are separated by a comma. So I can specify VLANs in any sort of way that I really want. Now, let's see this configuration. So if I do show spanning tree MST configuration here, I can see, okay, well, I have not mapped those other VLANs to, so I have created the map for instance 0, but what I need to do is I need to move those other VLANs to instance 1. So here I'm going to say from 6 to 10, it's actually going to go to instance 1. So if I do show spanning tree MST configuration, now I see that VLANs from 1 to 5 and 11 to 4094 are mapped to instance 0, and 6 to 10 are mapped to instance 1. Let's do the same thing on cat2. So I'm going to say instance 0 VLAN from 1 to 5 and from 11 to 4094, and instance 1 VLAN 6 to 10. So show spanning tree MST configuration. I can see that my configurations on cat1 and cat2 are the same. Well, almost the same. Let's not forget that the domain should really match. Let's confirm that the configurations are now the same. It's easier to do it side by side, so I'm just going to do it this way. And I can see that on switch 1 and switch 2, the configurations are the same. So going to cat1, if I do show spanning tree MST, now I'm going to see that only MST0 appears to be active. What happens on cat2, show spanning tree MST? It's the same thing. Why is it showing me only instance 0 as active when I have created all the VLANs? Well, the reason here is that there are no ports that utilize any VLANs from the range that is mapped to instance 1. So that instance 1 is not activated. Similarly to what you would have with the rapid per VLAN spanning tree or the normal per VLAN spanning tree or traditional per VLAN spanning tree, is that if you don't have any ports that require the instance of the spanning tree, it's simply not going to be activated. So how do we add ports to any of those VLANs? Well, very simple. What I'm going to do is I'm going to configure the range of ports, so interface range fastnet 23 to 24. I'm going to declare them as trunks, so switch port trunk encapsulation.1q, switch port mode trunk, and I'm going to do no shutdown here. Interface range fastnet 23 to 24, switch port trunk encapsulation.1q, and switch port mode trunk, no shutdown. So now, at this moment, if I do show spanning tree MST, what I should be seeing is two instances of spanning tree running, and that's exactly what I can observe now. I have MST0 and I have MST1. Now, another observation that we have to make is that this switch here is the root switch for the internal spanning tree, and that this one here is the root for MST instance 1. I wanted to reverse this. I wanted to use both ports. And if I have this set up like this, I'm going to have 23 and 24 designated ports on both sides. For both instances of spanning tree. But this is not what I want on the other side. On the other side, what I want is actually slightly different configuration. What I would like to have is that for one instance, 24 is blocking, and that for other instance, it's actually forwarding, so that I can utilize both links. That is easily done. So this is what I'm going to do. On cat2, I'm going to go to interface, fastnet23, and I'm going to say spanning tree, MST, instance 1, for example, cost, and I'm going to increase this cost. Let's say that I'm going to set the cost to be 450,000. So if I do show spanning tree MST now, what I'm seeing at this point here is that for instance 0, port 23 is forwarding, and for instance 0, port 24 is blocking. But for instance 1, the roles are actually reversed. I can see here that port 23 for VLANs 6 to 10 is going to be blocking, but it's going to be forwarding for VLANs 1 to 5. Now, this is the reason why MST exists to begin with. You see now that for the traditional implementation of per VLAN spanning tree, or the rapid per VLAN spanning tree that Cisco implements on Catalyst switches, we would have needed a lot more instances to actually accomplish this. With the multiple spanning tree, we just did 2 instances and we are utilizing both links. This is it, as simple as it gets. Multiple spanning tree MST on its own is rather complex spanning tree operation. However, the most intimidating and most complex part of it is how it actually interoperates and cooperates with different kinds of spanning trees. So in this module, we are going to talk about MST compatibility with the rapid spanning tree, or rapid PVST. We are going to talk about MST's interoperability with the Cisco's PVST, and of course, what happens when we have multiple MST regions. In a single network, we can run different kinds of spanning tree. We can run MST, the PVST, rapid PVST. We can run traditional spanning tree if you are running non-Cisco switches, if you are using non-Cisco switches. And all of these different parts of our network that are running different kinds of spanning tree are considered to be spanning tree domains. So a simple spanning tree domain would be a single switch where all ports are in VLAN 1 and we have a single instance of per VLAN spanning tree. That one switch makes up a single spanning tree domain. On the other hand, we could have a more complex spanning tree domain that consists of an MST region consisting of, let's say, 10 switches and 5 instances inside that MST that has 150 VLANs mapped across these different instances. This is also considered to be a single spanning tree domain. This entire network can still work and interoperate and can function, albeit it might be a little bit difficult to troubleshoot for an inexperienced or even more experienced network engineer, but it will still work somehow. So to see how that kind of a network will work, let's take a look at our spanning tree domains. So let's say that we had a part of our network that was running traditional spanning tree. So let's say that these switches here are running traditional spanning tree. Let's just make them Cisco switches. So these are running PVST spanning tree. Let's say that we have a couple of switches there that are running rapid per VLAN spanning tree, and they are somehow interconnected here. And let's say that we have an MST region where we have different switches that are running the MST. So these regions here, or these MST domains, these spanning tree domains, could be interconnected, and we don't really care how the internal connections look here, because this is all going to work, because both rapid per VLAN spanning tree and the MST, they are backwards compatible with the PVST. So this is somehow going to work out. However, MST takes this compatibility with different kinds of spanning tree one step beyond this simple backwards compatibility, this operating in the old mode. As we know, all these ports that are connecting to different kinds of spanning trees, we are going to call them boundary ports. And Cisco is simply going to display them as bound ports. So remember, these are not bound to anything, these are boundary ports, these are the border ports. And these switches here, we can call them the border switches because they are sitting on a border of our MST domain and something else. what we can say from MST's perspective, so we are looking at the MST's perspective of this network, we can say that this whole network here is something that we call a common spanning tree. So this is a global view of the network. This is the spanning tree that keeps this whole network loop free. However, inside the MST, we still want to preserve our visibility into different instances, into different topologies that we might have, but we really want to hide all that complexity from the outside domains that don't actually understand what MST does. So for that reason, inside our MST domain, inside our MST region, we are going to be running something that is called the internal spanning tree. Now, internal spanning tree is nothing other than the MST instance 0. But what happens if we have multiple instances? Well, if we have multiple instances, these same BPDUs are going to be used to carry this information, but they're going to have information about something else, the MST instance spanning tree there. So we are going to have information about, let's say, instance 1 or instance 2 or instance 3 and so on. So we can say that in our spanning tree network, in this large network that consists of multiple spanning tree domains, we are really running, from MST's perspective, three kinds of spanning trees. We are running the common spanning tree, we are running the internal spanning tree, and we are running per instance spanning trees inside the MST domain. If you are asking yourself, what's the reason for this complexity that we are seeing here, I don't blame you. I was struggling with the same concept for a very, very long time, and then it struck me. Even though this whole network would operate without this complexity that MST introduces, it actually makes network run just a little bit better, just a little bit smoother than it would without this complexity. And that's the whole goal in the networks. We want the networks to run in a more optimum way. We don't want to have network that is backwards compatible and slow when something fails. We know that PVST will take a long time to converge after the failure. Rapid PVST is somewhat better, but if we all switch back to our backwards compatible operational modes, what we are going to end up doing is running PVST everywhere, or traditional spanning tree, which is not the champion of speed when it comes to convergence. So for that reason, MST introduces this additional level of complexity to make things like run just a little bit faster and a little bit better when things go wrong in our networks. And as we know, from time to time things do go wrong. The basic idea is relatively simple. It is, let's hide the MST region from everyone else by representing it or presenting it to everyone else as a single switch. But inside the MST region, let's maintain the knowledge of what is happening inside the region itself. In other words, from the perspective of the MST, the network may look like this. So let's say that we have 3 switches that are in the MST region, and let's say that we had a single switch that runs PVST here. So this may be the actual network, or how the actual network looks. From the perspective of the PVST, what PVST is going to be seeing here is going to be the PVST switch connected to another PVST switch with 2 links. Now, we know that this switch here is actually our whole MST region. And in our MST region, we are running our internal spanning tree with probably the internal spanning tree instances, or MSTIs actually. And here we are running the common spanning tree. So here we have our internal spanning tree that maintains this topology, and then here, using our common spanning tree, the PVST is going to perceive this whole MST region, this whole set of switches, the group of switches, as a single switch. This allows for more optimum operation inside the MST domain, while maintaining relatively simple perspective for everyone else.